So I want to give you a diagram of how to set up your power areas. So this is the general style. Now I'm going to show you a diagram for how everything connects. Here we'll start with your battery bank. This battery bank could be remote and can be any size. I like to have 30 amp fuses for every single thing that leaves the battery bank and near the battery bank. So here we have from the battery coming out to a power inverter. The power inverter changes your power from 12 volt to house current at 120. They come in 115 volt, 110 volt, and 120 volt. I suggest a 120 volt because some things like coffee makers have to get the 120, and I totally destroyed a brand new coffee maker by plugging a 120 coffee maker into a plug that was only fed by a 110 power inverter. So you really got to look for that inverter, and you want to size it appropriately. I would go a little larger than you think you want. Up here you have a transfer switch. This is only if you also intend to plug into shore power at an RV park or something. The transfer switch, basically, when you plug the plug into the shore power, disconnects from the power inverter and the battery, and then when you unplug there's a little delay, and then the transfer switch starts drawing back again off the batteries. So here we have a battery charger. If you're going to be using land power, may as well charge your batteries while you're at it. What's important is that you're feeding the battery charger only from the shore power. So directly from the shore power is how you feed your battery charger. You do not want to feed your battery charger directly through an inverter in any way, because you'll just create this constant cycle between your battery and your battery charger. So if you're using a battery charger, you might want to speak to an electrician, help you with that part of hooking up the transfer switch, and this should be independent and from the shore power. So you have a power panel with all your breakers in it, comes out and runs into your unit. Here you have your solar panels on the roof, I suppose. They always come through a 30 amp fuse. They come into a solar controller. The solar controller will monitor the battery and will stop from overloading your batteries and damaging them. Often there is a dump attachment where you would take the power that is otherwise coming in and not being used, and you'd send it to fans or heaters or hot water or whatever you'd like to do. Here you have 12 volt fuse box, and these have the typical little car fuses that would all come through a 30 amp from the battery. This would be used to feed your 12 volt water pump, any other 12 volt fans like in a toilet. Some of the composting potties have a constant ventilation, and anything that's going to get a direct 12 volt, like charging perhaps your phone and things like that. So this is how you would set up your system. Solar panel into the solar controller, from the solar controller to the fuse and then battery. Land power into an automatic transfer switch. So only when it's plugged in is it functioning in that regard. Your power inverter also goes through the transfer switch, and then each come up to the panel, off to your outlets and lights and whatnot. Your battery charger only fed directly from the shore power, never from the power inverter directly. Everything with 30 amp fuses. You can get these fuses economically that are reset fuses, so you go over and you just throw the switch again. They're handy to have, and they'll save you money rather than having to replace fuses. So I hope this is helpful for those of you that are trying to plan what you're going to do. Remember, get a 120 volt power inverter. You'll be happy you did.